Hi there, Sanjay Gangal from EDA Cafe. I'm here with Vijay Chobisa, Senior Director of Product Management, uh, HAV at Siemens EDA. Hello, Vijay.
Hello, Sanjay. How are you?
I'm doing great. I'm assuming HAV stands for Hardware Assisted Tools, Hardware Assisted Verification.
That is correct. Hardware assisted verification. Yes.
Okay. Now, Vijay, when I look at uh, what hardware assisted vendors are talking about, it is always so heavily weighted on total capacity. Can you explain to me why this number is so important to companies using hardware assisted tools like emulation and prototyping?
Yes, Sanjay. So the total capacity is very important because customer would like to know upfront that the system they are purchasing is capable of emulating the full configuration of their SoC and system. And as our customers gate counts are rising, customers are employing 2.5D, 3D IC stacking as well as chiplet to build these large and complex chips. So in order to verify these large and complex chip, you need a platform that can handle that capacity scaling in a very reliable way. And for these large system, reliability is very, very important. I would like to stress on this point is, when you are validating large chips, you need to have a system which is very reliable. Also, Sanjay, it is very important to understand that emulating 1 billion gate design versus 10 billion gate design is very different. It poses a significant scaling challenges for both the hardware and software. The another aspect I would like to highlight here is the complexity of the software workload and this software application. Like for certain application like AIML, high performance computing, not only these chips are very large, but the type of workload and number of workload you need to run to optimize your chip, your system are very large actually. And these workloads are very long, like they run for billions of cycles. So you need a platform that can handle that capacity of these large chips, but also provide a reliable platform to run this long workload uninterrupted. One other aspect, Sanjay, I would like to highlight is, for our customer verification and validation requirement has changed over the years. Yes, certainly you need to verify the functionality of your chip and your software, but there are system level aspects which are equally important, and those need to be validated at system level. Like for an example, is your system safe? Your system is secure? Are you able to deliver the required performance in the given power budget? So in order to achieve this, you need to create a system level representation or system level view that include your chips, they include the interfaces your chip has, and the software. So for that reason, the total capacity is very, very important to address the growth in the size of the chips, but also uh, the growth in the number of workloads and uh, the duration of those workload you need to run. So that's why I think the total capacity is talked a lot, and it is a very important aspect.
Okay. And so it sounds like spec capacity is like the maximum speed you can drive a car, something we rarely do. So how does spec capacity translate into usable capacity?
So I think it is very important for our customers to understand the difference between the spec capacity versus the usable capacity when they are making the buying decisions. So let's take an example. Let's say you need to verify a chip that require 10 billion gate of hardware capacity. That could be emulation capacity or prototyping capacity. So you go ahead, you make a purchase of 10 billion gate capacity based upon the spec capacity advertised by the vendor. Okay, you have your system, that is as big as 10 billion gate. Once you start assembling all the pieces of your SoC and you start building the platform for the verification, let's say your chip doesn't fit. Okay, so now what do you do? So at this point, like, you are running against the time, you need to complete the verification, you need to tape out the chip. So you have two options. One option is buy more capacity from the EDA vendor, right? That needs the budget. You may or may not have budget approval for that. Second option is you cut your design, you create the mock-up models and do the partial verification. With that, you may run into risk not verifying the system to the full extent. So I think it is very, very critical that our customer understand that the difference between spec capacity versus the usable capacity. Spec capacities are the measurement done in the ideal environment. The usable capacity is when you put the system in the real world scenarios, you load those complex chips, your real world chips. What is the capacity you need? How much capacity you need to emulate your complex chips?
And does usable capacity vary across the emulation and prototyping platforms that are available from different companies? And what are the main reasons for this variation?
So Sanjay, that's a very good question actually. Let's understand where the gap, right? Where this gap is coming from. So it depends upon the technology and architecture used by the vendor to build the hardware system, right? So for the Boolean processor-based hardware, have severe power challenges when you try to connect multiple towers together to build a configuration that can handle the large chips. So verifying the large chips like 8 to 10 billion gate become problematic due to power consumption and cooling requirement of these systems. Also, due to high power consumption, this system is faster. So you have the reliability problem. So the hardware reliability create the challenges for running these large chips, but also running those long workload which can run to 8 to 10 billion cycles. So other one is like for system which are hardware system built with the commercial FPGAs. So when you try to connect multiple towers together for high capacity design, the capacity degrades significantly and also performance drops significantly. So for an example, let's say the one tower is 3 billion gate. You connect 4 towers together. Since capacity scaling is not linear, it does not add up to the 12 billion gate. So you have a problem. If you have bought a system to verify a 12 billion gate design, you are connecting this 4 system together, you are not getting 12 billion gate. For Veloce, the technology and architecture is designed to scale. And we are doing our own chip, we are doing our own system, and we are doing our own software. So there is no third-party component involved here. We are doing the purpose-built accelerator called Crystal Chip. Is designed to provide the capacity scaling, the faster compile time, and full debug visibility as designs start scaling from as small as 40 million gate to 10 billion gate all the way to 44 billion gate. So the system and software, in addition to chip, they are playing key roles in the capacity scaling and the turnaround time required by our customers. So for Veloce, the capacity scales linearly as you connect multiple towers together. We have customers today using 10 to 12 billion gate system to validate a single instance of the design. So that is huge actually. So Veloce CS system is architected and designed to scale all the way to 44 billion gate. And capacity scaling is applicable to our emulation platform, which we call Veloce Stratos CS. It scales from 40 million gate all the way to 44 billion gate, and is applicable to our enterprise prototyping platform called Veloce Primo CS. And this system also scales from 40 million gate to 44 billion gate, right? So saying that, I support 10 billion gate, 20 billion gate, 40 billion gate is one thing, but putting this complex system, making sure those systems are running reliably in order to map those large chips and run those long workload which are running for billions of cycle is very, very critical for our customers. So in summary, what I would like to say here, if you are doing the large chips and you are running those long workload which are running for hours and days, Veloce CS has the right solution for you, both for emulation platform as well as prototyping platform. So, and also you can get a lot more information from our website about entire Veloce CS family.
Okay, and Vijay, there is a new announcement this week coming from Siemens EDA. Can you talk to us about that?
Yes, Sanjay, interesting that you asked. So we are continuing our investment and our roadmap. So in last February, as you know, we launched our Veloce CS platform, that is emulation, enterprise prototyping, and software prototyping. Those were our hardware platform. Now we are launching an Inexis, which is which will enable our customer to do shift left. They can start assembling the system very early on before the RTL is ready, the months, or quarters. And this platform will allow our customers to start with virtual models, and once as the RTLs are getting ready, they can move to the hybrid environment, and finally the fully accurate models of the SoCs are ready, they can move to the full RTL model. And virtue of this new announcement is, which is called Inexis, it allow our customers to move from virtual to hybrid to fully accurate model while running exactly same workload, same software applications. So it provide a continuum and a link from virtual to hybrid to fully accurate. And when there is a gap, they can go back to hybrid, they can go back to virtual model and see where is disconnect. So we are very excited to adding this offering to our Veloce family, and you will hear more about this announcement November 7th on Thursday.
Okay, and Vijay, I think you already touched upon many points of how Veloce CS platform is better than the competition. Is there anything else that you would like to add?
Yeah, I think one other thing I would like to add is, Veloce, the Strato Scalable, Veloce CS scalability is not only a hardware and software platform, but if you see the trend in the industry today, these platforms are going to data center, and the trend is toward the virtual. And the Siemens has a very differentiated offering for providing customers an environment where they can do the verification using virtual environments. And that's where one of the aspect of our architecture is very important is co-model channel. And this co-model channel allows a communication between the software model running on the host and the design running in the emulator. And that's where this Inexis platform we are announcing, it is gonna get highly benefited by the co-model technology, the bandwidth it is providing for interaction between software and hardware.
Okay, and what is the best way for our audience to find out more about Siemens hardware-assisted verification solutions on the internet?
Yeah, so our website is fully equipped with the Veloce CS platform. The users and customer can go to our website to find more information.
Okay, and Vijay, is it okay if I ask you a few personal questions?
Sure, Sanjay, go ahead.
So, what do you do for fun outside work, or what is your personal passion?
Sanjay, yeah, if you are working for hardware, where you build emulator, enterprise prototyping, and pro FPGA software prototyping, there is no time for fun. Uh, yeah, just joking aside, Sanjay, I do a couple things. The one is I do the gardening, so I spend my weekends working in the garden. But also, when I get the time, I would like to do the meditation. So I spend some time on meditation, and I love my friends. So I would like to go spend time with my friends as well. So.
Okay, and in the gardening, are you doing more flower gardening or vegetable gardening or both?
So I think all three actually. I have flowers like roses and other type of flowers, but mostly it is the fruit trees and the vegetables like tomatoes, uh, the lettuce, chilies, all those kind of the vegetables.
Oh, awesome, awesome. And what kind of fruit trees do you have?
So I think I have about 14 fruit trees, citrus trees, persimmons, cherry, the pomegranate, apples. I think I have 13, 14. I have Indian tree also we call, curry patta, which is get used
Hmm,
to make, Indian vegetables. So.
pretty awesome, pretty awesome. I love to come to your place and check out some of the fruits, fresh fruits there.
Absolutely, Sanjay. I will love to have you at my home. So anytime.
Okay. And Vijay, Now, can you also share something about yourself that most people at Siemens EDA who work with you don't know about you?
Um, I think Sanjay, that is a difficult question. Actually, I'm very open. People know a lot about me. Uh, yeah, I'm not sure people know that I do the meditation. So I think that's the only thing you asked me. So I publicly say that, but only my friends know. Not many people know that in my spare time, I do the meditation. So
Okay, and is the transcendental meditation something else?
I'm the Krishna devotee. So I just meditate to Lord Krishna. So
Okay, okay. And with your final question, cats or dogs?
dogs.
Yeah, do you have some?
No, I don't actually, but my friends have dogs, and I love when I go there. I love playing with the dogs actually. So
Okay. Well, thank you so much, Vijay, for taking time to record this interview. Have a great day and stay safe.
okay, thank you, Sanjay. Bye bye.
Okay. Yeah, this is Sanjay Gangal from EDA Cafe.